Okay. Okay, generated adversarial network again, and varying, or there's a lot of different versions for GRM. Basically, GAN is an image. You can think of it as image generator, especially for image to image. Translation, okay? Which means you transfer one image into another image. For example, you can transfer a black and white image into a color image, okay? Or you can transfer an watercolor painting into an oil painting. 水彩画转成油画 or even sketch to oil painting, 把素描转成是油画都可以. Okay, all this. Well, actually, you saw this before, such as UNet. Okay, UNet. UNet is for semantic segmentation, but actually the output of UNet can be any other image. It does not have to be, but we use a total different strategy. Okay, is especially for GAN. Hinton say GAN is the breakthrough right after convolutional neural network. Okay, GAN, especially for image. So that will be our last topic today, okay? I'm going to introduce some very popular and good for you, especially for industrial engineering. What I mean is especially for manufacturing. 在制造业里面，大概我会介绍几个很重要的。It has been developed a few years ago, but I still consider it as the best model in terms of the training time, inference time, okay, compared to the most popular or up-to-date model, diffusion, okay, or even transformer. I still don't think transformer is the best model, but anyway, that will be the topic next for the data pattern class, especially for time series data. Okay, anyway, let's go back to GAN. Okay, generated adversarial. Okay, 生成对抗网路. Okay. It can think of this as a game theory, okay? Look, 跟那个赛局理论很像, okay? There's two players. Okay, each one try to win over the others, so that they might have to think of a lot of strategy. Okay, even for baseball, okay, the pitcher and the hitter, they might think, right? The pitcher how to throw the ball so that the hitter might miss the ball, and the hitter might think what the pitcher will throw a curveball or fastball or anything. So anyway, they have to struggle between two games so that they can win. Okay, a little bit like this. But anyway, the game it composed two deep network. Okay, this two deep network can be mostly in the original. Again, it is based on convolutional neural network. Of course, now you can change it to transformer or diffusion model. That'd be fine. But we stick on convolutional neural network. But the idea is the game, okay, it contains a generator. Of course, when I say generator, it's nothing but a neural network. Okay, 它还是一个网络。Now we stick on convolutional neural network. Okay. Now the other one is discriminator. Again, the discriminator is also a neural network. Okay. Now the purpose is for classification. The discriminator is trying to use for classification. The generator, of course, is to generate image. Okay? This generator network is used to create an image based on some criteria. And then the discriminator will try to identify the input image is a true image or a synthesized image created by the generator. That's it. That's the whole game. So YuanZe is game theory. The generator, let me see, what is the notation it uses? Use G, represent the generator. Use D to represent the discriminator. Okay? So we have an input. So we use the generator to create now let me put something Z. Okay, we input something and then this generation model will create an image. Okay, and we expect this synthesized image will be as close to or similar to or exactly the same as the real image. Okay? The real image. That's the purpose of generator. But at the meantime, for the discriminator, depend. Wow. I should give. Let me give S prime. Will be equal to 1 if X prime is real. It's a real image. Okay? It's a you take it from your smartphone or any camera. Otherwise, it should be 0. Okay? If X prime is generated is created from this one. Okay? Anyone follow me? Okay, as F prime is the input to the. So G and D, they must be against to each other, right? The purpose for G generator is trying to create the synthesized image as closer to the real image as possible. But the discriminator says no matter how the synthesized image is closer to the real image or not, I can always tell which one is true or which one, or I put it, is fake. Okay? It's not true. It's synthesized. But it's not any real image or real picture or real photo. Okay? So both are against to each other. Which means the generator will create X hat so that it can cheat the discriminator, and then it cannot tell which one is true, which one is fake. Of course, for the discriminator, we input an X, then the discriminator, I put just D. In what case the training for the game will be successful? In what case? Especially for the generator, because I want to generate a synthesized image. It's so real, like the true image. So usually the output got to be a softmax, right, for classification. So in case it is real or fake, the softmax value is equal to 0.5 and 0.5. In that case, the discriminator cannot tell which one is true, which one is fake. And then in that case, this achieves the purpose, right? Achieve the purpose. It was so real, like X. It's not possible, but that is the goal of game. It's a breakthrough after this year, okay? A very smart way. And after that, here comes a lot of different versions of game. Okay, keep improving the image generation. Okay, but that's the basic idea. Okay, remember, for any game, we have a generator and we have a discriminator. A discriminator is nothing but a classifier. Okay, it's a classifier. 分类器, and it is a binary classifier. Let's say a binary classifier. And generator, you can think of generator, it's just a decoder. Like we mentioned about autoencoder, right? We input something into an encoder, then we find the latent variable, then we input the latent variable into a decoder. Then we converted the input into an image. So you can think of generator is a decoder. Okay? Discriminator as a classified. They are all constructed, or the architecture of CNN, okay, or transformer, or any neural network. Okay, that's the idea. Okay, so we can start it from here. Now, remember, for any game, we have two parts. One is generator G, the other one is discriminator D. And the goals are totally different. Okay? G tried to make the generated image, okay, as closer to or as real as the true one. But the discriminator says no matter how the synthesized image is, I can always tell which one is real, which one is fake. Okay, that's the idea. So when you talk about the game theory, the equivalence 就是当他们两个都是0.5 okay? When both the softmax output is 0.5 in that case, if this is 0.6 and this 0.4, then I can still tell it's real or not, right? Even the fake one could be very close to the true one, because it still have a high softmax, right? But anyway, I can tell the difference. Okay, so here's the idea. The first version of the game is quite odd. It is odd because you know what is the input for the game? A series of random number runs through. You might wonder how can I transfer a random number into an image? But that's the power of neural network, no matter what you input. So first you create, in the original version, usually you input 100 random number sequence, in sequence. 100个随机乱说. Then you go through the generator, as I mentioned, it's a decoder. Then you will convert the random number into an image. Because it does not have to be an image, or it can be a time series data. But anyway, we focus because we talk about computer vision. Okay, then this generated image, then we input another discriminator, which is another network. Then we go for, then you can simply use a sigmoid function because you can replace it with softmax. That'll be fine. Why the original version put it sigmoid? Because sigmoid varies between 0 and 1. Okay, 0 and 1. So actually you can replace the output activation function with the softmax. Anyway, it's either 1 or 0. Okay, 1 or 0. Or 1, 0 for real, or 0, 1 for fake. Okay, you can do something like that. Okay, that's the basic structure. That's it. Okay, that's GM. That's it. So just remember the input, okay? Just say we'll follow some distribution, but mostly we just use a uniform. Of course, you can input a Gaussian random number, that'll be fine, okay? It doesn't matter, okay? It doesn't matter. Okay, so everyone follow me so far, okay?
Yep.
Okay, good, okay. So this give you, anyway, it's just more similar like that, okay? So first it generates, okay, a random number that will follow standard normal distribution, okay? And then you convert, because this random number is a vector, Okay, for example, general 100. Then you convert it into two-dimensional because the output is an image. So we convert this one-dimensional random numbers, okay, vector into a two-dimensional, okay. And then we go through, you need to do some upsampling. Just think of this as a decoder, nothing but decoder. Okay, you will do upsampling and convolution, then you will create an image. Okay, then finally we input this to a discriminator. So if real, then we output 1. If fake, we output 0. Okay, with the softmax. So for this case, you can see it just use one single node for the output because it does not go for softmax. Well, actually, you can use softmax, but when you use softmax, you need two nodes, right? One for real, one for fake, but it simply use one single node with the activation of sigmoid, okay? Sigmoid, so that between 0 and 1, okay? We expect if you have a good generator, the output, the softmax value should be 0.5, okay, 0.5, then you cannot tell the difference, okay? Okay, so that's the basic structure of the original version of GAN, okay? So I will skip the detail. Now, let's take a look how to train the model. So the most important thing is what? The loss function. The loss function. Okay? How can we tell the loss function? Okay? Did I say anything here? You use cross entropy, okay? The original version, you use cross entropy, okay? And as I mentioned, the probability for the real image should be 1, okay? For the generate or synthesized image, okay? Then we reverse that level, okay? Which means is 1 minus the level, okay? Now, so the objective, okay? The objective for the discriminator based on cross entropy is like this, okay? Now, D is our discriminator, okay? E means expectation, okay? Expectation. Now, suppose X, well, is the truth, okay? It is the truth. The data means the truth. The truth distribution, okay? P means distribution of the real, okay? Of the real. So, we take D of X, which is, then try to maximum, okay? And then we try to maximum. What is maximum? Because it's real, then this value is 1. It got to be 1, right? The output got to be 1. 1 is 0, okay? But everything will be negative because this value, okay? Because this value is between 0 and 1. So any value between the log of any value between 0 and 1 is negative, right? 知道我意思吧？最顶的时候是它最大值了，因为这个 D 嘛是几率嘛，啊它的最大值多少？它的值呢是介于0跟1之间。当它1的时候 ，log 1等于0，是它的最大值。 For example, if b equal to 0.5, log 0.5 is a negative value. It cannot be maximum. Okay? So now we try to find the discriminator, which means we need to train the neural network. Okay? So if x is come from the real image, or it follows the true probability distribution. Okay? Now here we have another term. If the distribution of any random variable z, as I just mentioned, we generate the random variable from a standard Gaussian distribution. Okay? So then, given z of g, this is a synthesized image, right? This is a synthesized image, so we subtract it. Okay? We subtract it. Then again we try to maximize it. Everyone follow me. I do show some explanation here, right? Okay. So as I say here, dx is discriminator. Okay. So if x is real, then d of x should be 1. Then you will meet the first term. Now, we input a random variable z, and then we use the decoder or the generator to create the fake image. And then the discriminator should be what? Should be the output. We expect it should be 0. It should be 0. Okay? It should be 0. Okay? So that's what we are doing here. So that's why we need to use 1 minus this value. Okay? For best, usually the value won't be 0. This value won't be 0. It will be very small. We expect that as small as 0.001, for example. Okay, it won't be 0. But 0.001 will be, okay? Anyway, 1 minus this value, it will be very close. Okay? Then we can maximum this value. So anyway, the first term is used for the real image. The second term is used. Is used for the real image. The second term is applied to the fake image. 假的 image， 这样可以理解吗？对吧？所以这边 that's why we want to put 1 minus the value here. Okay, because the value should be very small. Okay, so when 1 minus this value, then we take log. Then this value should be still very close to 0, right? 我要让它很接近0。But if this value is very large, then the value will fall away from 0. It won't be negative. Okay, everyone, follow me. So let me summarize one more time. This term is evaluate if x is a true image. Okay, the second term here is to evaluate if the output image is fake or not. Okay, so that we need to put 1 minus d. Okay, suppose x is a true image, and then the second one, this g of z is generated from random number, which is fake. Okay, so we try to maximize. We try to find all the convolution filter and blah blah blah, so that you can have a good discriminator that can always tell which one is real image, which one is the fake image. Okay? Good? Okay? And I won't say anything more about how to do the optimization, but anyway, it just again, backpropagation, just a backpropagation. Okay, so that's it. Okay, so you can take a look the what I explained here. Okay, don't just put log 0. Okay, just assume it is a very small value. Okay, don't put 1 minus 0. Okay, basically the output won't be 0. Okay， 不会是0啊，非常接近0。那1键将会0的时候，这个值就会接近0。Okay, now here. This is for discriminator. Now, this is for generator. As I mentioned, the generator, the purpose, the goal of the generator is try to fool the discriminator so that it cannot tell it's real or fake. Okay? So this is the generator. Now we try to minimize this term. Now we know this actually this term is just exactly like this term. Okay, just like this term. Okay. Okay. So again, we input Z, a random number. Okay. Then apply it to the generator or the decoder, okay? And then this discriminator value should be 1. We expect it to be 1. That's the purpose of generator. The purpose is not to be 0, but the purpose is to make it 1. 听得懂吗？我要让它几乎等于1哦，不是等于0哦。等于0就没有骗哦。Okay, when this value is very close to 0, which means the create the image is so far away from the real one, then the discriminator can easily identify the fake image. Okay, so the purpose is different, so that we try to minimize. Okay, we try to minimize this one. Okay, we are optimize G so that we can fool the discriminator. Okay, we can fool the discriminator most. Okay, I just put an example here. Okay, where the generator is well trained so that the G of X, which means we input random number, and the output of the generator should be very close to the real one. Okay? And then we expect the discriminator will result in 1. Okay, actually it won't be 1. Okay? It will be very close to 1. It will be very close to 1. Okay? So if the value is very close to 1, suppose 1 minus this value, suppose it is minus 6 power of 10, then the output will be minus 6. That's what we expect. That's why we make it minimum. Everyone follow me? Okay? 好，因为我们希望它接近1嘛，那假如接近1，那1减掉这个值，我们讲这个值不会等于，基本上不会等于1啊。我们讲是它们的差号是因为1减了，它的差值是10的负6次方，那你可以去 log 的话就负6嘛，也就是说这个值呢就要越小越好，因为它的最大值不会等于1。OK， 好，它的值，我们希望它接近1。OK， so it's equivalent to train G so that the V of G is minimized, so that the final objective function for the discriminator and the generator. Okay, let me say it again. This is the objective or loss function for the discriminator. Okay, and this is for the generator. Well, actually this term is nothing but just like this term. Okay, just like this term. Right? Okay. Anyway, our final objective is the mini-max problem. That is the problem for solving game. I didn't say you cannot solve the neural network model with mini-max objective, okay? But it's more difficult. But anyway, that's how we got here, okay? That's how we got here. Okay, so first we try to maximize, okay, the parameter so that this term will be maximized for discriminator. Once you have the discriminator, then we try to find the parameter for the generator that will minimize this term. So actually there's a conflict. So you need to do some iteration. When you improve the D, you might make G get worse. And then when you improve G, you might have to sacrifice some of the value of D. So you will iterate the struggle between each other until you will reach the equivalent point 0.5. That's what we expect, or until it converge. So basically, GNN, the training time is quite long, and sometimes it might fail, okay? Because our objective is not a simple minimum or maximum, but it's mini-max. When they say mini-max between G and D, they must struggle with each other, right? When you improve something, then you will get worse for D here. When you improve D, you might sacrifice G, right? If you just take a look at D, the best thing you can get here for fake is what? You generate anything so different from the real image, right? 就产生一个跟它一点都不像的，那你 D 不是都不会出问题吗？对吧？怎么看就不像嘛。可是呢 ，G 又说不行。No, you say no. You cannot generate anything that's so far away from the real. So that you have to struggle between these two. Okay, you need to come and back and try to improve. But that's the basic idea. I'm too slow. Okay. But that's the idea about the GN. Okay, GN. Okay, so let's what we can skip it. It just we input an image and to make the discriminator to identify as 1 or 0, and also we have a generator. Okay, creating the number. Just as expression, actually you don't need to switch the circuit. I mean this double E guy, they love to use the circuit. 你把它转过来 then 这个是假的 then discriminator. Okay, you can try. But anyway, that's the gradient. Okay, that's the gradient. This is the gradient. Okay, the gradient. This is the gradient. Okay, used in the backward propagation. Okay, use the backward propagation. So it's not easy to train, and sometimes you will collect. Okay. 哦，有时候它会垮掉。Okay, so I just give you more explain why we expected this to be 0.5 and 0.5. Okay, for real image and for fake image. Okay. Okay, so you have known this. Okay, And then I will say something how to solve it. How to solve it. Okay, even when you run a game from any public library, you may not need to know the detail, but it's important to know. Okay, what is the limitation? Okay, I will say something. Okay, about the so-called deep convolutional game, and later on here's another one called I'm sorry, W. Okay, I say V is because it's a German name. You know, in German there's no W sound. When you say BMW, yeah, it pronounced V. Okay. That's during the World War II when the English asked they might have a German spy. They were asked to say W. They cannot pronounce W. Anyway, okay, let's take a break. Okay. And don't forget your assignment number 5. Oh, one more thing before, especially for you, will it be okay for next week's presentation, oral presentation, if they do it in Chinese? I mean, all the slides must be in English, but is that okay? Yeah, if they okay, then I left the choice to you. Okay, you can do the oral presentation in Chinese or English, it'll be fine with me. But the slides must be in English. Okay? Okay, good.
等一下，想一下。ลิปปิ้งเลยลิปปิ้ง